Hello, in this video we are going to find the standard deviation and the variance for grouped data. So we are looking at a table here, and this table gives the frequency distribution of the daily one-way commuting time in minutes from home to work for all 25 employees of a company. Okay, so I do need to fill this in. So I have the commuting time for 0 to less than 10, that's going to be 4 employees. I have 10 to less than 20, that's going to be 9. 20 to less than 30 is going to have 6 employees. 30 to less than 40 is going to be 4 employees again. And then 40 to less than 50 is going to be 2 employees. And I've added some columns here because we are going to need those for our standard deviation and variance formulas. So let's get started. First of all, we need to know what type of formula we're using. So we want to start with the standard deviation, and that is going to be dependent on whether I'm using a sample of data or a population. And when I'm reading through this question here, it tells me that it's all 25 employees. So that keyword there is all. That is going to be a population. Okay, so we're going to use the population standard deviation formula for grouped data, and that is going to be as follows. So we're going to have the standard deviation is going to be the square root. Well, we'll do the square root last because it's pretty big here. We have, let's see, the sum of the midpoint squared times the frequency minus the sum of the midpoint times the frequency, that's squared, divided by the population size, n, and then that whole thing divided by population again, and then the square root of all of that. So that is going to be our standard deviation formula. And then the variance is just without the square root. So the variance is the standard deviation squared. So we need a couple of things before we do that. So first we need the midpoints of our grouped data. So the midpoint, you would take the lower limit and the upper limit, add them together. So I'm going to put m here for my midpoint. Lower limit plus upper limit, and then divided by 2. So there we would do 0 plus 10, which is 10, divided by 2. So 0 plus 10 divided by 2, that would give us a midpoint of 5. Then the midpoint of 10 and 20 would be 15. The midpoint of 20 and 30 would be 25. The midpoint of 30 and 40 would be 35. And the midpoint of 40 and 50 would be 45. All right, so we have the midpoint. We need, let's see, let's go ahead and do, we'll do the midpoint squared. All right, so we need a midpoint squared. Okay, so midpoint squared is going to be 5 squared, 25. 15 squared is going to be 15 times 15, should be 225. So 225. 25 squared, 25 times 25, 625. Then we have 35 squared, 1225. And then we have 45 squared is going to be 2025. Okay, so I need the sum of the midpoint squared times the frequency. So that's what I'm going to do here. I'm going to go midpoint squared times the frequency. So I'm going to do this column here, 25, or midpoint squared, times the frequency. So back to this employee, or this column here, number of employees, frequency. So first thing I'm going to do is 25 times 4. That's going to be 100. Then I'm going to do 225 times 9. That's going to give me 2025. Then I'm going to do 625 times 6. That's going to give me 3750. Let's see, then I do 1225 times 4. That's going to give me 4,900. Then I'm going to do 25 times 2, and that's going to give me 4050. And then for this part of the formula, I need the sum of that. So the sum of the midpoint squared times the frequency. So we can do a sum column here, and we're going to add those together. So 100 plus 2025 plus 3750 plus 4900 plus 4050 is going to give us 14,825. Okay, so that part of my formula is filled out, so I'm going to put that over here. Okay, so that would be, starting in the numerator here, 14,825 minus, I need what's going to be here, the sum of the midpoint times the frequency squared, over n. Well, I can go ahead and find n. That's the total population size, which it tells us here is 25. And let's see here. Then that is going to be also over n. And then this is all under the square root. So I need this value right here, the sum of the midpoint times the frequency squared. So I probably should have added another column in here, but we can go ahead and we can just do that over here. So we're going to go MF. So that's midpoint times the frequency. So that's going to be this column here times this column here. So I have 5 times 4. That's going to be 20. And I have 15 times 9. Let's see what that is. 135. I have 25 times 6. I believe that's 150. Let's just check. 150. I have 35 times 4. That should be 140. And then I have 45 times 2. That's going to be 90. So 4 times 5, 9 times 15, 6 times 25, 4 times 35, 2 times 45. And let's go ahead and find the sum of this. So I'm just going to go ahead and add all of these together. And that is going to be 20 plus 135 plus 150 plus 140 plus 90. So it's going to be 535. All right, so I can start filling this in. The sum of the midpoint times the frequency is 535. And I want to square that. All right, so I have all my numbers, so I can start doing my calculations here. So I'm going to pull my calculator up. Now I want to do order of operations. So up here, parentheses, exponent. So I do want to do this 535 squared. So that's going to give me 286,225. Okay, so 535 squared. We're going to divide that by 25. Okay, to do this right here. So I'm just going to go ahead and write that out. So that's 11,449. So let me just, so we have 14, and let's do this in a different color just so we can see a transition here. So we have 14,825 minus, we did 535 squared, and we divided by 25. That was 11,449. And then we're going to divide that by 25. And then we're going to take the square root. So let's go ahead and do that. So 14,825 minus 114,000. Nope, it was 11,449. There we go. We're going to do that. Then we're going to divide by 25. So we get 135.04. That is not square root, so that's the variance right there. Then we take the square root. So we want the square root of 135.04. So we're going to go here, just down here. Okay, so that is going to give us second square root, 135.04. 11 point, we'll do 3 decimal places, 11.621. Okay, so that is our standard deviation. And then of course, if we square that, so we just take that and we just go like that, answer squared, 135.04, that's your variance. So here we have our standard deviation. So this is just symbol right there for standard deviation, population standard deviation, 11.621. And then my variance is just the symbol is sigma squared. So population variance, 135.04. Okay, so we have our standard deviation or variance for our group data. So what we could say here is that we have the, let's see here. Well, we actually didn't find the mean. So let's go ahead and find the mean just so we can kind of make this complete. So population mean for group data is going to be right here. So we have mean, mu for mean, Greek letter M. The sum of MF divided by M. So we actually had already found that, right? So the sum of MF was this 535 right here. So 535 divided by 25 would give us the mean of this data. So that's going to be 21.4. Okay, so what we could do here is we're going through and we're starting to do applications of standard deviation, is we could say that the mean commuting time for all 25 employees of this company is 21.4 minutes with a standard deviation of 11.621 minutes. So what that means is that mean commuting time, so average commuting time, 21.4 minutes, about 21.5 minutes. But then you have that standard deviation. So again, that's that give or take. So give or take about 11, 12 minutes there. Okay, so some people, you add 11 minutes. Some people you subtract 11 minutes. There's your standard deviation. So you're going to have a range there. So that's what it's doing. So the standard deviation is giving you that measure of spread, measure of dispersion, the range value here. So give or take 11 minutes is what you're going to say there. Now in the next video, I'm going to show you guys how to do this in a calculator and on Excel.